Now we have started with the design of staircase. The staircase can be used to move from one floor to the another floor. That is, it can be used for the vertical circulation in the buildings. Now first step is to calculate the approximate depth of the slab. Generally the staircase can be designed just like your slab. So first step is you have to calculate the effective depth of that slab, which is similar to your slab that we are already studied. So d is equal to, that is effective depth of the slab, which is equal to span divided by L by D ratio into modification factor. And this L by D ratio can be depends upon the type of support condition, and modification factor will be depend upon the which type of the steel we are providing. Or another way to calculate the overall depth will be the, we have to assume for 1 meter effective span 40 to 50 millimeter will be the overall depth. That is, the thumb rule can be also used for calculation of the effective depth of the slab. Now second one step will be the calculation of the loads acting on the slab. Now if you are considering the staircase, it will be having the two parts. One will be the, that is load on the incline part, that is load on this part of the staircase, and second one load on this landing. So first step we are considering the load on the incline part, that is the load acting on these steps. So first will be the self weight of the waste slab. So first self weight of the waste slab will be given as BD25 into under root of R square plus T square divided by T. Now R is nothing but your rise and T is nothing but your trade of the staircase. Now generally we are considering that is 1 meter, and this D will be the overall depth of the slab, and this 25 will be the effective weight of the slab, and second load will be the floor finish, and third will be the self weight of the steps. While calculating the self weight of the step, what we are considering, the steps will be just like your a slab having thickness equal to T, and this thickness will be given as rise divided by 2. Then self weight of this step will be given as B into T into 25. B will be, again we are considering 1 meter, T will be your thickness of the slab, and which is given as rise divided by 2. So this is the formula for calculating the self weight of the steps. Then the last load acting on the staircase will be the live load acting on the stairs. Now total load acting on the steps will be considered as a, that is weight of the waste slab, then floor finish, self weight of the steps, and the last will be the live load. So these are the 4 loads acting on the inclined part of the staircase. Then next one we have to go for the calculation of the load on the landing part. If you are considering the landing part of the staircase, the weight of the step will be the deducted, other weights are to be same, that is weight of the waste slab, which is again given by BD into 25, then floor finish and live load. So these 3 loads are acting on the landing. So while designing the staircase, we are considering the load on the inclined part because it will be the more than the load acting on the landing. Hence for the calculation of the bending moment, we are considering the load acting on the inclined part of the staircase. Now next step is we have to calculate the bending moment. Again we are considering the staircase will be the simply supported, which will be subjected to the load of W. Then bending moment is given as WL square by 8. Now we are calculating the bending moment. Once we are calculating the bending moment, then we have to go for the check for the depth we are already provided from the bending moment consideration. So this bending moment is equal to R into BD square. So R is nothing but the constant for moment of resistance. It will be depends upon the grade of the concrete and grade of the steel. B is the, again we are considering 1 meter, and this D will be the required depth from the bending moment consideration, and this bending moment value we are getting from this one. Bending moment is equal to WL square by 8. And the last step is, once we are getting the bending moment, then we have to go for the calculation of the main steel from the bending moment consideration, and we have to go for the calculation of the distribution steel. It will be considered as a 0.12% in case of the HYSD bars and 0.15% in case of the your mild steel. If you study the different types of the staircase that are generally used in the residential and the commercial building or the public buildings in the course building construction and material, generally the types of the staircase used are the dog-legged staircase. This is the cotton turn staircase. Then the next type of the staircase used is the open well staircase. then bifurcated staircase, and the open well staircase with quarter space landing, and the circular staircase. All of you know the what are the values of the rise and trade that can be used in residential building, and the values that can be used in the commercial building. All of you also know the different relation between rise and trade. All this information can be required while the designing a staircase.